On January 27th, 2026, a group of scientists in Washington, D.C. moved a clock forward. Not a real clock, a symbolic one. The Doomsday Clock, maintained since 1947 by the Bulletin of the Atomic Scientists, now sits at 85 seconds to midnight. Footnote 1. That's the closest it has ever been. Closer than during the Cuban Missile Crisis. Closer than the height of the Cold War. Closer than any point in the entire atomic age. But this number is subject to change without notice, meaning that between the date this video published and the time you watch this video, things could have gotten a lot more optimistic, or a lot less. Here's the thing about that clock. It's a metaphor for a very specific kind of anxiety, the fear that humanity might do this to itself. Nuclear war, unchecked climate change, engineered pathogens, an AI system nobody quite knows how to control. All human-made, all optional in principle, all still on the table, according to the people whose job it is to track them. Now zoom out, really far out, 13 billion years out. The universe has had time to produce, by conservative estimates, hundreds of billions of opportunities for a civilization like ours to emerge, look up, and start broadcasting. And as far as we can tell, listening with every instrument we've built for 65 years, nothing. Footnote 2. Not one confirmed signal. Not one. There's a name for the thing that could explain both of these facts with a single, uncomfortable idea. It's called the Great Filter. And depending on where it sits, that clock in Washington is either a footnote or the whole story. What the Great Filter actually is. In 1996, an economist named Robin Hanson, not an astrophysicist, an economist, which matters because this is fundamentally a probability problem before it's a physics problem, wrote an essay trying to explain something that should have bothered everyone a lot more than it did. Footnote 3. The universe is incredibly old. It is unfathomably larger than we can even imagine, even though in our minds we keep telling ourselves we comprehend the enormity. And by every calculation astrobiologists can run, it should be loud. Even a vanishingly small probability of life arising per habitable planet, multiplied across the billions of planets in our galaxy alone, and multiplied again across the billions of years those planets have existed, should produce a galaxy, an observable universe, that shows some trace of somebody else. Radio signals, megastructures, waste heat from a Dyson swarm. Anything. Instead, silence. Hanson's answer was that somewhere between dead matter and a civilization that is spread across the stars, there must be at least one step so improbable that it filters out almost everyone who attempts it. He laid out roughly 9 major transitions on that path. The right kind of star system, the emergence of self-replicating molecules, simple single-celled life, complex cells, sexual reproduction, multicellular life, tool-using intelligence, and so on, up through a civilization capable of interstellar colonization. Footnote 4. Somewhere in that sequence, or possibly spread across several points in it, sits a bottleneck so narrow that, of all the trillion opportunities the universe has had, it has let through, as far as we can currently tell, exactly one. Us. Maybe. Life may have found a way on Earth, but statistically speaking, possibly almost nowhere else, so far as we have discovered. Here's the part of Hanson's argument that should genuinely unsettle you, and it's not the part people usually focus on. It's not just something is rare. It's what that rarity implies about direction. If the hard step is behind us, if we already did the improbable thing, whatever it was, sometime in our evolutionary past, then congratulations, we're through the needle's eye, and the future is statistically wide open. But if the hard step is still ahead of us, if it's not abiogenesis or the eukaryotic cell, but something like surviving your own technological adolescence, then the silence isn't good news. It's a track record. Every civilization capable of asking this question anywhere, at any point in cosmic history, may have hit the same wall we're currently approaching, and none of them made it through. That's the whole question this episode sits inside. Not, are we alone? We've already spent a sub-series on that. This is assuming we're rare or even unique. Was the hard part already behind us, or is it still coming? The case for the great filter is behind us. Let's make the optimistic case first, because it's a real one, not a consolation prize. Life on Earth got started remarkably early, within a few 100 million years of the planet becoming even marginally habitable, geologically speaking, almost immediately. Footnote 5. That's actually a data point in favor of abiogenesis being easy, not hard. If it took that little time on the one sample we have, it's plausible that wherever conditions are right, chemistry gets there fast. That would locate a chunk of the filter later, not at step 1. But there's a genuine graveyard of candidate hard steps in between. The jump from simple prokaryotic cells, the bacterial kind, no nucleus, no internal complexity, to eukaryotic cells, the kind with a nucleus and internal machinery, appears to have happened exactly once in 4 billion years of life on Earth, and it took roughly 2 billion years to happen even that once. Footnote 6. Every complex organism on this planet, every animal, plant, and fungus descends from that single event. If it's that hard, and it only had to happen once for Earth to end up with us, then multiply that improbability across a universe that needs it to happen independently over and over on other worlds, and you start to see the outline of filter. The jump to multicellularity is another candidate, though this one seems to have happened independently several times in Earth's history, which paradoxically makes it a weaker filter candidate, not a stronger one. Footnote 7. The emergence of sexual reproduction, the Cambrian explosion of complex body plans, the specific sequence of mass extinctions that happen to clear ecological space for mammals rather than, say, keeping the dinosaurs in charge indefinitely, all plausible bottlenecks, all debated, none conclusively located. This is the genuinely maddening part of the behind us case. It's nearly unfalsifiable from where we're standing. As mathematician David Aldous and others studying Hanson's framework have pointed out, the amount of time a step took doesn't reliably tell you how hard it was. Footnote 8. A step could be extraordinarily improbable and still happen relatively fast in geological terms. You're only ever looking at the one timeline that succeeded, which tells you almost nothing about how many timelines nearby failed. We are structurally trying to reconstruct the difficulty of a lock by only ever examining the one time it got picked. The case for the great filter still being ahead of us. Now, the version of this argument that keeps existential risk researchers up at night. In 2020, Oxford philosopher Toby Ord published an estimate, deliberately rough, explicitly not precision mathematics, that humanity faces roughly a 1 in 6 chance of an existential catastrophe within the next 100 years. Footnote 9. Not a 1 in 6 chance of a bad century. A 1 in 6 chance of civilizational collapse or extinction. For comparison, Ord estimated that natural risks combined, asteroid impacts, supervolcanic eruptions, stellar explosions, add up to something like 1 in 10,000 over the same period. Nuclear war and climate change each land around 1 in 1,000. The two categories that dominate the total are ones with no precedent in Earth's 4 billion year biological history. Engineered pandemics at roughly 1 in 30 and unaligned artificial intelligence at roughly 1 in 10. Footnote 10. Sit with that ordering for a second. The risks nature has been testing against life for 4 billion years. The asteroids, the volcanoes, the stellar radiation are, per Ord's estimates, roughly 1,000 times less dangerous to us than the risks we have invented in the last 80 years. We're not worried about what almost killed the dinosaurs. We are worried about what we might build next. Ord revisited these numbers in 2025 and found nuclear risk trending up, climate risk trending down, and the picture on pandemics and AI genuinely mixed. No clean verdict either direction. Footnote 11. Which brings us back to that clock in Washington, sitting at 85 seconds, the closest to midnight it has been since scientists started keeping it 80 years ago, citing exactly the same categories. nuclear arsenals, biological threats, and now, for the first time as a headline factor, artificial intelligence. Footnote 12. Here's why this maps directly onto the great filter question. If the thing that reliably ends technological civilizations turns out to be the moment you invent something more powerful than your ability to wisely control it, nuclear weapons, engineered biology, self-improving machine intelligence, then that's not a uniquely human failing. That's a predictable stage. Every civilization that gets far enough to ask the Fermi question would, by definition, have already passed through the biological hard steps and arrived at the technological ones. If the filter is there, it wouldn't just explain our silence. It would explain everyone's. How close we've already come. If the filter is ahead of us, it's worth asking. Have we already brushed against it? October 27th, 1962, during the Cuban Missile Crisis, a Soviet submarine, B-59, was being depth-charged by American ships that didn't know it was carrying a nuclear torpedo. Under Soviet protocol, launching required agreement from all 3 senior officers aboard. 2 voted yes. 1. Vasily Arkhipov voted no. Toby Ord, in his own accounting of the century's closest calls, ranks the broader Cuban Missile Crisis as the single moment humanity came nearest to nuclear war, with contemporaries at the time estimating the odds of escalation anywhere from 10 to 50%. Footnote 13. September 26, 1983. Soviet early warning systems reported 5 incoming American nuclear missiles. Protocol called for immediate retaliation. Lieutenant Colonel Stanislav Petrov, on duty that night, judged the reading to be a false alarm, a rare confluence of sunlight reflecting off high-altitude clouds, and did not report up the chain. He was right. It was a satellite malfunction. 2 people, 2 decisions, neither of them a president, a general, or anyone whose name most people know. Between them, they may be a meaningful fraction of the reason this episode is being made by a human civilization rather than not being made at all. This is the uncomfortable arithmetic of near misses. We don't actually know how many almost catastrophes it takes before the real one lands. Ord's 1 in 6 century scale estimate is, in a sense, already trying to account for exactly this. A world where the technology capable of ending things exists, is proliferating, and is being managed by fallible institutions making judgment calls in real time, sometimes correctly, sometimes by the width of one submarine officer's nerve. Why we can't actually locate it. Here's the honest complication, and it's the reason serious researchers resist declaring a verdict on this question. In 2018, Anders Sandberg, Eric Drexler, and Toby Ord published a paper reworking the Drake equation, the classic formula for estimating the number of communicating civilizations in the galaxy, not by changing the estimates, but by changing how the uncertainty in those estimates gets handled. Footnote 14. The standard approach multiplies together a set of best guess numbers and gets one confident answer. Sandberg, Drexler, and Ord instead modeled each parameter as a range spanning multiple orders of magnitude, because that's what the actual scientific literature supports, and then ran the calculation as a distribution rather than a point estimate. The result, a meaningful probability, by their model somewhere around 1 in 3, that we are entirely alone in the Milky Way, and a non-trivial chance we're alone in the entire observable universe. Footnote 15. Not because the universe is hostile to life, because our uncertainty about how hard each step actually is turns out to be so large that we're rare, but not due to any single dramatic filter, is a live possibility. Alongside there's one enormous bottleneck, alongside there's several smaller ones stacked in a row. Life may or may not always find a way, and the honest answer is we genuinely do not know which, and anyone who tells you otherwise is selling oceanfront property in Kansas. This matters for the behind us or ahead of us question because it means the silence itself is compatible with almost every version of the story. A universe where the filter is safely in our past looks, from here, identical to a universe where the filter is dead ahead. The only way to actually update that probability is either to find independent evidence of life elsewhere, which would suggest the early steps are easy, pushing the filter later toward us, or to survive long enough as a species to find out empirically which side of the bottleneck we're standing on. So, is the worst behind us or still ahead? The genuinely honest answer is that nobody gets to know that in advance. Not from a formula, not from clock in Washington, not from 4 billion years of Earth's own biological history, which only ever ran the experiment once and can't be rerun to check the odds. What we do know is that two people on two separate nights 46 years ago made a judgment call that kept the experiment running. The universe does not require our recognition to proceed, but it turns out our proceeding, at least so far, required a handful of very tired people making the right call under enormous pressure in the dark without knowing the stakes were quite this cosmic. There's still a lot of universe left to look at. Whether we're the ones who get to keep looking is, as it turns out, up to us. It's a Tuesday. Go hug somebody who works in nuclear risk reduction.